Okay, so this is the second video of 1-1 frames of reference, displacement, and position. And we were looking at a position time graph, and we had gone through the first 2 seconds of motion, and we were discussing the fact that the position time graph is awkward for us because we're used to seeing or visualizing motion occurring horizontally, and the way that a position time graph is, it puts the value for position on the y-axis because that's the dependent variable, whereas time is the independent variable. And the problem we have is that we confuse the drawing on the graph with the actual path of the motion. We have to realize that the motion is simply taking place in a horizontal direction. It's either moving to a positive or negative direction. But from the graph, we can't help ourselves. Our brain goes to the idea that the path on the graph is the actual path of motion of the object. So we have to get that confusion dealt with right away. It's not. It's just showing us how far away from the origin that the object actually is. Okay, so now we've gone 3 seconds, and after a total of 3 seconds, the object has moved to a position of 50 units, and we can see that right here. So 50 units at 3 seconds, and the graph now gives us a visual impression that the object is still traveling at an angle of 45 degrees to the north, but that's not true, right? This is not the path. But even though the motion continues to be to the right horizontally, and if we show the corresponding motion diagram over here, we can see that after 1 second, I was at 10 meters, right? And then after 2 seconds, I was at 30 meters, and then after 3 seconds, or at time 3, I was at 50 meters. So this shows us a more accurate representation of the of what corresponds to what's in our brain about the motion. This is the motion of the object. This is also the motion of the object, but it's more difficult to interpret. But as we'll find out, this graph, this type of graph, provides us with a great deal of information that we need, that we can't get from our motion diagram. So go ahead and go to the next slide. Now let's say that during the 4th second of motion, the object moves back towards the origin. And on the horizontal motion diagram here, I've shown that, right? I'm at 50 meters, and during that next second at time 4, x4 equals 0 meters. So I'm at 0 meters. So this is showing the fact that I traveled from a position of 50 meters to a position of 0 back to the origin at a constant velocity. The fact that it's a straight line means that it's a constant velocity. But the graph gives us the impression now that the object is moving at an angle downward and to the right. It's actually just traveling back to the origin to the left on the horizontal frame of reference. Okay, let's go to the next slide. And then let's say in the last second of motion, it continues past the origin and continues to a position of 50 units to the negative side of the origin. So the motion diagram up here again shows that my last motion, my last displacement is from 0 to negative 50. So I went from here to here to here, back to here, and back to there. And this diagram shows that as well. Again, I am traveling at a constant velocity because the motion is a straight line. If I was traveling at a non-constant velocity, then the motion would be curved. Okay, so this is what a motion or a position time graph looks like. We also have velocity and acceleration time graphs that we'll use. But I just wanted to demonstrate this idea that we can graphically show the motion of an object to kind of complete this thing that we can describe the motion of an object either using words through language or mathematically through formulas, or graphically as we've shown here. So to summarize these points and bring us back to our learning target, we've described motion using language, mathematically, and graphically. We will learn to use all three to effectively communicate our understanding of motion and how motion is related to forces and how forces are related to energy. Okay, so this is the end of the, not the discussion, but this is the end of the class notes for topic or unit page 1, which is just talking about how we talk about motion in three different ways: language, mathematically, and graphically. So now we're going to go to the actual first topic of this this unit. Excuse me. And that's going to be the unit entitled Frames of Reference, Position, and Displacement. And so all you need to do is just keep going to the next slide and continue to fill out the worksheet. And I'm just going to go to the next slide. So let's take a little quiz here. It's just one question. So I want you to watch this video, this 6-minute video. I'm not going to watch it with you. Just before you answer this question, click on this video. And the point of this video is to just sort of get you to start thinking about where you are. I'm sorry. Getting you to think about where you are in space. And this kind of makes you feel a little small. But this idea of your position in space is a very important position in terms of describing motion. In order to be able to describe motion, you have to be able to tell where in space you're at. And that's just the whole point of the movie. Now, the movie doesn't have anything to do with the question. The question does have to do with where we're at in space, but the movie doesn't address this in the question way that I'm asking in the question. And so after watching the attached video, think about your position in space and answer this question. To create a frame of reference for a description of motion in one dimension, which two of the following possible components are required? I've said note the answer to this question is not in the video. The purpose of the video was simply to get you thinking about how to describe your position in space. So in order for me to define my position in space, where I am at in space, I need a frame of reference, and that frame of reference requires at a bare minimum two things. And I want you to see if you know at this point, before we talk about it, what those two things actually are. What are the two things that my frame of reference requires? So I'm going to give a wrong answer. I'm going to say an x-axis, which is wrong. And I have to do that so that I can go on. I have to submit something in order to be able to advance the slide. So you make your answers. I'm going to go ahead and submit mine. And it told me that I got no answers correct. So there are two answers that you need to supply. I only supplied one. But go to the next slide after you're done. So for this part of the discussion, our learning target will be, I will be able to define the term frame of reference, state why this concept is important, and qualitatively describe the motion of an object relative to one or more frames of reference. Okay, I need to be able to qualitatively describe something with words, just using my words. How would I describe the motion relative to a frame of reference? And we'll describe what that means here in a minute. Now, we can only understand the motion of an object if we know how the motion relates to its surroundings. Hopefully that makes sense. I can't really say the motion of the object is this, 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 and this if I'm not comparing that motion to the surroundings of the object. Okay? So we need to understand this. And you will be able to write the definition of frame of reference. You'll be able to state two reasons a frame of reference is important. Given a motion scenario, you'll be able to correctly describe how the motion of an object is perceived depending on related frames of reference, 80% of the time. And given a motion scenario, you will be able to create an accurate frame of reference and correctly define the direction of motion related to the frame of reference 80% of the time. Hopefully you'll be able to do those things 100% of the time. So go ahead and go to the next slide. Okay, so let's ask this question next. Consider, if you were going to describe the motion of some object, tell me what you think the absolute very first thing you would need to know about the object is. What do I need to know about an object to begin to be able to describe its motion? And I'm just going to write, Marshall was here, because that's all I want to say, but I have to say something so I can move on. So I'm going to type that in and submit it, and you can go ahead and create your own statement. So, defining the position of a quantity of matter, the need for a frame of reference. So consider the quantity of matter, this little yellow ball on the line below. If this quantity of matter is in motion in that straight line there, in order to be able to begin to describe the motion, what is the first thing that we have to know about the quantity of matter? Okay, and this may be too obvious to think of, but go ahead and think of this. Okay, so I've already sort of asked that as a little bit of a quiz, but here's a little bit more of a direct question, so I want you to write down your answer for this. I'm going to type out what I think the answer is. The first thing that we need to know about the quantity of matter, and it's not what I think it is, it's what it is. What is the first thing we need to know? The first piece of information we need to know is, where is the object in space when it begins the motion? Okay. In other words, I have to have, in order for me to describe the motion, I need to be able to say it goes from one place to another place. Well, I have to be able to say where that place is. I have to be able to say what its initial position in space is. So its initial position, and that's what we'll call it, the initial place where the object exists. And we will define some very specific things that we need in order for this to occur. Okay, so go ahead and go to the next slide. So in order to be able to define, whoops, did I miss something? Go back here. Okay, so I left out, I apologize for this, I left out blank 7 in order to be able to define its position. Or I'm sorry, in physics, the place that a quantity of matter is in space is called its position. Okay, so for some reason I left that sentence out. In physics, the place that a quantity of matter is in space is called its position. Okay, now we've got to go a little bit farther than that. In order to be able to define the position, what else do I need to have? And this is the main point of this discussion here, is I need to have a frame of reference. Okay, I've got to be able to tell where something is, and in describing where that something is, I have to relate it to some reference point. So a reference system is a system we can use to define the location or position of an object in space. This requires that we have a starting or reference point that we will call the origin. Okay. This further requires that we know in which direction, when traveling from the origin, the values increase. This requires some type of system of, we're going to say, coordinates. Okay, so in order for me to be able to see where I am in space, I need a frame of reference. I have to relate that position to something. Okay, I can't just say, oh, it's in space. I have to say it's in space 9 meters from the origin in such and such a direction. And oh, by the way, I'm going to have to stop this particular video and go to the next one because my 15 minutes are up. Okay, so we'll stop there. Next video.